Alright, in this video we're going to look at how to use the Desmos graphing calculator to do exponential regression. And we're going to do it using this data here, which looks at the cost per megabyte of storage space on computer hard drives from 1980 to 2004. So I'm going to switch over to Desmos here, and the first thing we need to do is create a table of the values that we had. So I'm going to click Add Item and choose Table. And you don't have to, but I'm going to go ahead and rename my variables T and C, for T being the time in years and C being the cost. And then I'm going to fill in the data here. So I'll type in year 0, the cost was $192.31, and now I'll fill in the rest of the data. Alright, so I've finished entering the data now, and if we wanted to get an idea of what this looks like, we would need to adjust our graphing window. So notice my input values go up to 24, so I'm going to adjust it to go up to, say, 25, and then my outputs here go up to 192, so I think I'll put my maximum at 200, and now we can see our data here. And you notice that it is a decreasing shape that looks a lot like a decreasing exponential. So that's what we're going to try to do, is find an exponential regression. And so to do that in Desmos, we write the equation form using a tilde instead of an equal sign. And the tilde is that key in the upper left-hand corner of your keyboard. So I'm going to write C tilde a times b to the t, right? So this gives me the form of my equation, a times b to the t, where t is the input variable. And that gives me the regression. Now, Desmos uses a different technique for regression than almost anyone else. So the results that we have here are not going to match the results that you would get from a TI calculator, from Excel, from almost any other piece of technology. And so because a lot of the times we need to match up with other technology, we are going to turn on this log mode. And this log mode adjusts Desmos's technique to match that of other technologies. So let's click that, and that will give us an answer that matches other technology. Now you'll notice that in some ways this result looks worse than the one that we had before. But what this mode does, the log mode does, is it minimizes the percent error at each point rather than minimizing the absolute error. And so in some ways this is actually a better regression than the standard Desmos one. But anyway, with log mode enabled, then we can read off R value, which is the correlation coefficient, tells us how well the data, the equation fits the data. And then we can read off the parameters. So A here is the initial value in my exponential, and B is the base of my exponential.